Welcome back. In this video, we're going to look at the division by surds. So, division by a surd does not actually involve division. So, division by a surd does not actually involve division. By conventions, surdic fractions are simplified by rationalizing the denominator. So recall a fraction. The upstairs of a fraction is called the numerator and the downstairs is called the denominator. Now going on, this is done by effectively multiplying by 1. So some examples of this would be consider the fraction 2 root 3. And what you notice is that the denominator, so the downstairs of this fraction, has a surd in it. And as mathematicians, we don't like that. So what we're going to do is we're going to remove this surd by multiplying the downstairs by root 3, or multiplying the denominator by root 3. And to get away with doing that so we don't change the value, we're going to multiply the numerator by root 3 as well. So we're going to go 2 over root 3. And we're going to multiply both upstairs and downstairs. So root 3 by root 3. So root 3 over root 3, that would be 1. So we're not actually changing a value here. Rather, we're just changing the form. So root 3 times root 3, that's going to be 3. And then upstairs in the numerator, we've got 2 root 3. So if you don't believe me, grab your calculator and put in 2 over root 3 and have a look what the value will be, and then do the same for 2 root 3 over 3. And what you'll find is the values will come out to be identical, but the difference being in that in our second form over here, what we've got is a rationalized denominator. Looking at example 2, notice that the form that we're working with is significantly more complicated than in example 1. Rather than having a single term expression in the denominator, we've got a multi-term expression. So the question is asked, how do we deal with this? And what might not be obvious is we're going to use a tool that we've seen before, in that consider the difference of two squares. So a plus b, if you do the difference of two squares, you get a plus b and a minus b, and that will equal out to a squared minus b squared. So we're going to use this tool here to help us make this example here in a more friendly version. So what we're going to say is that our expression 2 minus root 3, or 2 minus 3 root 2 over 3 plus root 5, we're going to get the denominator and do something called conjugate and go 3 plus root 5. So on the bottom it will be 3 minus root 5. And that's under 3 minus root 5 as such. We're going to multiply everything together like this. So using the form that we can see with the difference of two squares on the right here in purple, down the bottom in the numerator, we're going to expect to see 3 squared minus root 5 squared. And then up in the numerator, it's going to be 2 times 3 minus 2 root 5 minus 9 root 2. And then plus 3 root 2 times 5, like so. And then evaluating all of that, we're going to get 9 minus 5 in the denominator. and then it will be 6 minus 2 root 5 minus 9 root 2 plus 3 root 10. And then evaluating everything downstairs, or upstairs, will go 6 minus 2 root 5 minus 9 root 2 plus 3 root 10 all over 4. Now looking at this, you might instantly say, well, we just made it worse. But the reality is, consider when we started this example, we started off with a surd in the denominator, and the end goal is to have this expression here in a form that doesn't include a surd in the denominator. And in this case, we've simplified it down to there's only a 4 in the denominator now. So in fact, we have made things better, even though upstairs looks a little bit more complicated. So what we've learned in this short video here is how we can move, or how we can manipulate our surds into a form that will make it easier to do mathematical operations in the future.